Today we're going to talk about how to factor integers. Okay. So first of all, before we talk about factoring integers, who can tell me what integers are? Royce, what do you think? What are integers? You have any idea? Right. What sort of numbers? Right. These are numbers, but like 0.27. Is that an integer? No. So how would you describe integers? Yeah. You want to try it? Well, 0.27 is a real number. Every number on a number line is right. Is a real number. Patty?
All positive whole numbers and all negative.
Right. Give me an example. -3. All positive whole numbers and all negative whole numbers. So yeah, whole numbers are only positive, but if you put negative, so it's numbers like this: 0, 1, 2, 3, 4, and so on. Those are whole numbers, right? And then if you include the negatives of those numbers, then you have integers, right? -1, -2, -3, and so forth. Right? So that's what these are integers. Now we're going to be factoring then these integers. Does anybody know what we mean by factoring integers? Two people have not. Samuel, what do you think? Good. So you have to write them as a product. You multiply them. So for example, when you write 56 as 8 times 7, is 8 times 7 same as 56? Yeah, Matthew, isn't that right? Now we wrote 8 times 7 as 8. So these two numbers are multiplying, right? 8 and 7. So when you write things as a product, okay, this is how you factor things, okay? You guys remember like the difference between factor and terms? Terms are separated by what? Addition sign. Factors are then separated by multiplication. You can think of it that way. So as you can see, we factor 56 because we wrote it as a product. Is this the only way to write 56 as a product? No. What's the easiest way to write 56 as a product? Yeah.
56 times 1.
Yeah, 56 times 1. So that's, you could write that. Or can I write 2 times 2 times 2 times 7? Is that still 56? Yeah, because 8 times 7, right? 2 times 2 times 2 is 8, right? So yeah, there are many ways of writing numbers as a product. So when we do this, we call it over 14 times 4, and there are many others. Oh, what about -4 times -14? Does that work? Does that give you 56? Yeah, all these examples are examples of factoring in integer. Okay, so write this down. When you write things as a product, so write this down. You have factored 56. In other words, as you write them as a product. Samuel, did you have a question? Yeah.
When factoring, are you allowed to use exponent?
We'll get there in a minute. Okay, very good question. Okay. So the question is, are you allowed to use exponential form? The answer is yes. Actually, as a matter of fact, later, when you factor things, I'm going to ask you to write it as a exponential form. So we'll get there in a minute. Okay. Can I write 56 as half times 112? Is that okay? Isn't no?
No.
Isn't 112 twice of 56? So isn't half times 112 56? Yeah, it is. But this is still factored. You know, these are still factors of 50, right? 56 half. But you're sort of right. Usually we are interested in what sort of numbers when you factor things. Odd? Integers. Not. It could be odd. It doesn't matter. It could be even or odd. Doesn't matter. We want integers. So we're interested only in factors that are integers, and there's a name for it. We call them integral factors. So we're only interested in these factors to be an integer. You see how integral sounds like integer? So you can think of it that way. Okay. So you may see this on the test or your homework. They want you to. They may ask you to write down integral factors of some numbers and so forth. It just means the factors that are integers, right? Because half is not an integer, is it? Okay. So again, integers are like 0, 1, 2, 3, 4, and then -1, -2, -3, and so forth. Okay. No decimals or fraction. Okay. Any question? Okay. So if it does not say anything specifically, when they ask you to factor things, they want integral factors. Okay. Is that okay, guys? All right. All right. So that's an example. Give all positive factors of 42. Okay. So when they ask you something like this, first of all, what do you think they mean by give all positive factors? Yeah.
All the possible ways you can, all the possible ways you can multiply two numbers to get 40, two positive numbers, integers to get 42.
Good. Yeah, so what we mean by this is we want all the integers, right? An integer times what gives you 42? In other words, what goes into 42? That's what they're really asking. Does that make sense? So what number will go into 42? Let's start with the easiest one. What goes into 42? Samuel? 42 times 1. Isn't that the easiest one? So we have two factors that we could write about 42, right? What are those? 1 and 42, right? So you just, yeah, it's really easy to, it's nice to think of them as a pair. So yeah, so this is what I'm thinking in my head. Okay, so I know that to make 42, here are two factors, 1 and 42, right? And they want all of them. So is this the only way to write 42 as a product? No, you could use another number. Since I'm starting with 1, guess what I'm going to check next? 2. Does 2 go into 42?
Yeah.
Yeah, what?
21.
So isn't this nice to kind of write them as a pair like this, 1 and 21? Okay, let's think about then 3. Does 3 go into 42?
Yes.
Yeah, did you guys know that there's a rule? There's a nice rule, if you remember this. This is really nice. When you look at a number, you could tell whether or not 3 will go into that number. I mean, without really trying so much. There's a sort of a nice trick you could, yeah, what do you think, Aiden?
When you add both of them together, if like you take 42 and add the two numbers in it, like 4 and 2.
Exactly, those are called digits. You're right. So if you were to add the digits
That,
of the number, then what?
then it's a multiple of 3.
Exactly. So what's 4 plus 2, guys?
6.
6. Does 3 go into 6?
Yeah.
Yeah, so if that sum of the digit, right, goes into 3, then 3 must go into 42. So 3 times what gives you 42?
14.
There you go. You see, isn't that nice? That's a really good rule to remember if you want to know whether or not 3 goes into a number. So for example, 111. Do you think 3 will go into 111? Yeah. What's 1 plus 1 plus 1? 3, right? So does 3 go into 3? Yeah, so it turns out 111, right? It doesn't look like 3 will go in, but turns out 3 goes into, it has to, okay? If the sum of the digit adds up to multiples of 3, right? Then 3 must go in. Okay, let's look at 4. Okay, since I talked about 1, 2, and 3, let's do this in order, right? Isn't that nice? Because I don't want to forget any of them, okay? I don't want to like skip any of them. So does 4 go into 42?
No.
No, okay. You can kind of see that it doesn't. What about 5?
No.
5 has a nice rule too. The number must end with 0 or 5, right? Then 5 goes in. Okay, so obviously this 5 doesn't go into 42 because it ends with 2. What about 6? Does 6 go into 42?
Yeah.
Yeah, you can kind of see if 2 and 3, both of them go in, 2 times 3 is 6, right? So how many times does 6 go into 42?
7.
Okay, 7. 7 times. Right. Okay, now the next number that we would think is 7. You see how it sort of wraps around?
Yeah.
So then I could just stop now. I don't have to keep going, right? Because I know that 7 will go in, 14 will go in, 21 will go in, 42. Does that make sense? So as soon as it wraps around, that's when you stop. So have we found all positive factors of 42? Yeah. What are the factors? In other words, what numbers times what gives you 42? What are these factors that you could use? In other words, what goes into 42? What integers? Yes, sir.
4 times 42, 2 times 21, 3 times 42.
Did you say 4 times 42?
Wait,
1. 1 times 42.
1 times 42.
So how would you list all these factors? You would
Like in order.
in order. So it'd be 1,
2,
2, 3, 6,
42. I mean, no.
7.
14, 21, 42.
Exactly. So here's the answer. Now, what if they ask for negative factors of 42? Well, it could be negative, right? Negative 1 times what gives you 42, guys? Negative 42. But they only ask for positive. It's sort of, right? That's really not that hard, right? If they ask you negative, it would be negative of all these, right? Because negative times negative gives you positive. So that's not a big deal. So if they ask you to give all positive factors of a number, do you know what to do now? So start with the easiest one, right? Start with 1 and that number, and then keep going. Does 2 go in? If it doesn't, try 3 and 4, right? Until it wraps around, and you list all these numbers, right? Right? Pick any of these numbers. It will go into 42, wouldn't it? Right? Are there any other numbers other than these that are integers? No, that's it. Okay. So can you do something like this for your homework tonight? Okay, any question? Okay. So this is one of the type of questions that they may ask today. They're going to ask, give all positive factors of some number. Okay. That's easy, isn't it? Any question? Okay, good. Okay, and some of these numbers, when they ask you to find the factors, you would only see that number and 1 as its factor. That's it. Can you give me an example of which number would have factor of 1 and itself only? Can somebody think of a number? Dana? 1. Okay, sure, 1. 1 and itself, 1. Are there any other numbers? Yeah.
2.
2, sure. 2 is only, the factors of 2 is only 1 and 2. Are there any other numbers? Mimi? 3, sure. 3 works. Any others? Yeah. 5, sure. Yes, sir.
7.
7, yeah. 11, sure. 11 is, yeah. 17, sure.
Are these prime numbers?
13, yeah. And Chuck, what do you say?
Prime numbers.
These are called prime numbers. You're exactly right. So these are, so here's how we define it. Prime number is, or they sometimes they just, in short, they just say prime, okay, instead of saying prime number. Is an integer, okay. So it can be like 2.7 or something, okay. And an integer greater than 1. So is 1 a prime number?
Yes.
Yeah.
No.
No, it says it has to be greater than 1, so 1 doesn't count. So greater than 1. So what's the smallest prime number?
2.
2, exactly right. Greater than 1, that what? That has no positive integral factor other than 1 in itself, exactly. And here's some example. 2, 3, 5, 7. Of course, it keeps on going, okay? So I'll write that down, I'll wait. And I think a lot of you already knew this. So, so we just talked about prime numbers. So let's switch your gear a little bit. And do you guys remember prime factorization? This sounds sort of hard, but turns out this is nothing more than anybody know. So we just talked about prime, so it has something to do with prime, right? What do you think they mean by, like they say, oh, do a prime factorization of these numbers? What do you think they mean by this? 2 people? See it? Have you? If I told you, okay, let me give. Many times they refer to this as factor tree. How many people have heard of factor tree before? Okay, prime. When they say prime factorization, it's the same thing as factor tree, and you just write them in. Only thing that's different is you write them in exponential form. That's all, guys. Do you guys remember factor tree?
Yeah, is that what you're
Yeah, like you have a number, you have branches, right? And then at the end, when do you stop? When you reach, huh? But after you do all these branches and stuff, right? You have 2 branches, right? And then when do you stop? Yeah. When all the factors are prime, and those are the leaves. Like tree has leaves, so those are the leaves. Anyway, we'll do an example. You see what I mean, okay? Do you guys remember this? Factor tree? Yeah. Okay. So let's do one in a minute. Here we go. So they may ask you to do something like this: find the prime factorization of 504. Okay, let's do this one together since it's our first time doing it. Okay, so 504, first you start with 504. We're going to do, again, I just told you, prime factorization is nothing more than doing a factor tree, right? So look at 504, and I'm going to have 2 branches from 504. What numbers goes into 504? Let's do the easiest one. What has to go into 504? Since it's even, you know this number has to go in. What's the rule for even number? 2 has to go into an even number, isn't that right? 2 times what gives you 504? 250. 2 is correct. And you see how I circled 2? Why do you think I circled that 2? That's your prime number, right? Do I need to circle 252? No, that'll be wrong. That's not a prime number, is it? Because I can already tell it's an even number. So you only circle your leaf. That's your leaf or your prime number. You see why it's called factor tree? This tree has leaves. Okay, so 252. And again, it's even. Let's just do it as easy. I mean, you don't have to do it this way, but I'm going to do it as easy as possible. Since it's even, I know what has to go in, class. 2. So I'm going to write 2 times 120, 27 or 26? 26, right? 126. So you know that, again, I circle my leaf, right? That's my prime, 2. But I don't circle 126. That's not a prime number. Again, 126 is an even number, isn't it? So what goes into 126? Isn't this easy? Just 2. Again, 2 goes into 126. And notice how I'm writing 2 on the right side, so that because I wrote 504 on the right side, you know what I mean? So I have rooms on the right. I have more room on the left. So I'm going to write 2 on the right again, and then 63. Now, I didn't circle 63. That must, right? Because 63 is not a prime number, is it? We know it's not because what's 6 plus 3? 9. I know that 2 doesn't go in, right? Because it's an odd number. So clear? 63, what goes into 63?
7 times
3, right? Because 6 plus 3 is 9. We know that 3 goes into 9. So 3 times what gives you 63, class? 21. And again, I didn't circle 21 because look, 21, again, if you add 2 plus 1, if you add the digits, it's 3. So I know that 3 has to go into 21. How many times, guys? 7. And you know that 7 is a prime. So I stop right there. You see how I circle all my leaves? Okay. So how many factors do I have of 504 right now? 1, 2, 3, 4, 5, 6. I found 6 of them. So let's list all of them. And do you think it's a good idea to write them in order? From in increasing order? So I wrote it this way. Now, we don't stop here. And this is what Samuel said. What's the best way to write this in? Yes, what do you think? That's correct. You want to write this in, what form is this, guys? In exponential form. Okay, so please, when I ask you to write things in, when I ask you to do a prime factorization of a number, please write them in exponential form. And Aaron gave us the right exponential form. Okay. Any question? Is this easy? And please do them in order. Okay, in increasing order. It's much easier that way. Okay. Any question? Is this easy? So these are sort of a review sort of. And the reason why I did all this work is to do what we're about to do next. Can anybody guess where we're going with this sort of idea? Why are we talking about all these factors and prime factorization and so forth? Why do you think we do this? Yeah. Word problem? Not quite. So let's do an example. Let's see if we could figure this out. So let me ask you this. Can you think of a factor that is common in number 2 and 4? What factor is common in 2 and 4? What is it? 2. Would you not agree? Because what's a factor of 2? 2 and 1, right? What's factor of 4?
2 and 2.
2 and 2. No, there's a factor of 4. It could be 1, 2, or 4. So what's common factor in both? 2. Is that right? So write this down. A factor of 2 or more integer is called a common factor. For example, 2 and 15. What's a common factor of 2 and 15? Can somebody see? So we're looking for a factor of a factor of 2 or more integers. It's called a. So what's a common factor for 20 and 15? 5. Would you not agree? There's always a very easy. You could always get this. There's other common factor other than 5. There's a very easy one. What's another factor that is common? Claire? 3 for 20 and 15?
Oh, no.
Yeah, so 20 and 15, we said 5 is one of them. There's always an easy one. Yeah, Claire, we're trying again? 1. 1 is a common factor. It's really easy. Okay, so you know that 1 is going to be a common factor every time, right? If you have 2 integers, right? But of course, we're not really interested in that one. Okay. What about, can somebody think of a common factor for 108? 108. What would be a common factor for? Dana? 4. Would 4 be a common factor for both of these?
Yeah.
Yeah. Are there any other ones? Yes. Matthew? 2 is 1. And of course, don't forget the easiest one. What's the easiest one? 1, right? Okay, so you have 1, 2, and 4, and so forth. But is this always easy to see common factors for 2 or more numbers? Not all. I mean, these are easy because these are nice small numbers, right? But if I give you some numbers that are so kind of, right, large and stuff, it's not so easy to see the common factors, right? So guess what we're going to try to figure out today? Yeah. We're going to actually be looking at not any kind of common factor, because if I said, give me a common factor, you could always say 1. It's a very easy question. But I'm going to ask you to find the greatest. For example, what will be the greatest common factor for 20 and 15? It'll be 5. You can see it. What about 108? 4. We were looking for the, in other words, what does greatest common factor mean? The largest factor that is common for both of these numbers. Isn't that right? Or you could have more than 2. So that's what we're interested in. Okay? Because if I just said, oh, give me a common factor, you will all get 100%, right? You just have to write 1. Okay, that's easy. But I'm interested in the greatest common factor. And you'll see why in a minute, why we did all this work in terms of prime factorization and factor and so forth. Okay, some of you maybe already see it. Okay, so write this down. So this is, I mean, this is nothing then. So greatest common factor, GCF of 2 or more number is what? It's exactly what you just talked about. It's the greatest integer that what?
It's
That is common. And
two or more integers.
yeah, so this is how we, so for example, the greatest common factor, GCF, how many people have heard of GCF before? Yeah, GCF, greatest common factor, right? Of 2 or more integer is nothing more than the greatest integer that is factor of all given integers, right? Isn't, well, for example, like 20 and 15, isn't 5 the GCF? We just talked about that, didn't we? Isn't 4 the GCF of 108, right? Isn't this the greatest integer that is a common factor of both of these numbers? Yeah.
What does it say after the factor?
Of all given, of all given integer, given. Yeah. Let me fix that. Okay. Does that make sense? But as we said, many times it's not easy to see a greatest common factor, right? Of course, if the two numbers are sort of big and so forth. What's another way of saying? How would you describe? This is sort of a formal definition. How would you describe to somebody what is a GCF? What would you tell them? Yeah.
The largest number that can be divided into.
Exactly. It's the largest number. I wrote it this way. Biggest integral factor that will go into, right? 2 or 3 numbers. Isn't that what we're really looking for? Look, does 5 go into 20 and 15? Hello?
Yeah.
Yeah. And is that the biggest number that will go into 20 and 15?
Yeah.
Yeah. There aren't any other. So is 4. 4 is the biggest number that will go into 108. That's what we're basically saying. That's what GCF is. Isn't that right? So that's another way of thinking about it. Or this is same thing, right? These are different way of saying it. So let's do an example. Here's example 3. It says find the GCF of 36 and 90. And this is not one of those where you could just look at the problem and figure it out, right? On your own. You know what I mean? Like it's not as simple as the other ones. Okay, so what do you think we have to do for 36 and 90 so that we could actually, if you follow these rules that I'm about to show you, it's going to be really easy to figure out the GCF of these numbers. What do you think we have to do? What do you think? Think about what we just did all this time. Yeah, Dana, what do you think we should do? Yeah, you find the prime factorization of 36 and 90 first. Then it's going to be really easy to see what the GCFs are. Okay? So do we know how to do a prime factorization? Another word for that is simply do a factor tree. Everybody go ahead and do a factor tree for 36 and 90. Okay, so step 1, you do a factor tree to find the greatest common factor. Okay. Oh wait. Okay, step 1 for GCF, you do a factor tree for these numbers. Okay. Now, do they all have to look exactly like the factor tree? No. But at the end, when you write them in exponential form, should they look exactly like? Yes.
Yeah.
For 36 and 90s. Yeah? Go ahead. Try this. And check with your group. Okay, see if you have the same exact. So the tree doesn't have to look exactly like, but at the end, the prime factorization, when you write them in exponential form, they should look exactly like. Okay? Go ahead. Here's my factor tree. Does your factor tree have to look like exactly like mine? No, it doesn't. No, it doesn't have to. I mean, it depends on, because I started with 2. But what could you have done? You could have done 4 times what? You could have done 4 times 9, which is 36, right? You could have started that way, right? But anyway, but did you get these as your exponential form of these prime factorization? Yeah. Okay, good. 2 to the second, 3 to the second for 36. 2 to the first, I wrote that invisible one for you. 3 to the second and 5. Did you all get that? Is that okay? I'll wait if you didn't get. Check it. Make sure you have this. Okay. And now let me show you how to find the GCF. At this point, after you've done your prime factorization, remember I told you it's really, really easy to figure out your GCF. All you have to do is, turns out you could literally see your common factors. After you write things in, after you do your prime factorization and write things in exponential form, you could see your common factors, literally. How many people see the common factors? Not all of you? Okay, watch this. Okay, look at these factors. Don't worry about these exponents yet, okay? Look at 2. Is 2 a common factor? Yes, it is. How do you know?
It's on both sides.
Yeah, it's on both. It's on both of these, right?
Integer.
Integers, right? As a factor. Isn't 2 a factor of 36? Isn't 2 a factor of 90? So guess what? Your GCF of, we found the common factor. Have we found the greatest common factor yet? Is this the greatest common factor? No. We have only found the common factors. So far we found that the common factor of 36 and 90 was 2 and 2 and, yeah, 2 and, I'm gonna write 3. Is 5 a common factor? No. Is 2 times 3, is this my GCF? No, not yet. But these are my common factors. Would you not agree? You could just literally see it. That's why we did all this work, right? To do factor tree. Now the trick is, look it. We have to choose the exponents. So I could either choose 2 to the second or 2 to the first as my GCF. What do you think I should choose? 2 to the first or 2 to the second? Now remember, we're looking for the greatest common factor. We're looking for a number that is biggest number that goes into both, right? Now, would it be 2 to the first or 2 to the second? I'm going to say 2 to the first, raise your hand. I'm going to say 2 to the second. I'm going to say no, not. Okay, I'm only talking about in terms of 2 only. Don't worry about the 3 right now. Okay, so would 2 to the first going to both of them or 2 to the second going to both of them? 2 to the first. Can I choose 2 to the second? No, why not? Yeah, it's not in 90. There's only 1, 2, right? So you have to write 2 to the first. Is that okay? Because we want to make sure it has to go into both of them. If I chose 2 to the second, right? Hold on. If I choose 2 to the second, it will not go into 90, would it? Right? Does that make sense, guys? It would be too big, right? What about 3 to the second or 3 to, well, this time there's no, it's easy. This is both, they both have 3 to the second. So guess what? It's going to be 3 to the second, right? Wouldn't 3 to the second go into both of these? Does that make sense? So that's what you do. All you have to do is write down the common factors, right? Because you could literally see them and choose which exponent of these common factors. Higher one or the lower one? Lower one, because we have to make sure it goes into both of them. If we choose the higher one, would it go into both of these? No. So what's the answer? We should write it out. 2 times 9, which is what? 18. Turns out 18 is a number, right? It's the biggest number that goes into both of these. Is that okay? Samuel? I'm sorry? Are there other ways? Yes, there are. But this way actually tells you, yeah, but this way actually tells you why we need to do it this way. Okay, there's some shortcuts. So how many people got 18 as the answer? Raise your hand. Does that make sense? Okay, like I said, there are many different ways of doing it, but I want you to do it this way for now. So step 1, let's summarize. Step 1, you do the factor tree. What's step 2? How would you describe this step where you write down your common factors and choose the lowest exponent? Yeah.
Put it in exponential form.
Well, that's the factor tree part, okay? Then after you write them in exponential form, then what do you do?
And then you write them out as like the whole number and then multiply.
Okay, so I wrote it this way. You write the product of the smaller powers of each common factor. Isn't that what we choose? We write down the common factors and then we choose the smallest exponent. Isn't that what we did here? So this is sort of a summary of what we did. Is this okay? So I'll wait for you to write this down. We wrote the product of, we chose the smallest exponent of these common factors, right? Wasn't 2 and 3 the common factor? So go ahead, write this down. We chose first we did the prime factorization, which is doing a factor tree, write them in exponential form, and then we wrote the product, right, of smaller exponent of these common factors. 2 and 3 were the common factors. We wrote 1. Remember, if you look up here, yeah, this is 2 to the first is a smaller exponent and 3 to the second. Well, they were the same, so you didn't have to worry about it, okay? So let's do an example of 3b. This time, I was so nice. The hardest part of this is doing the factor tree. I did it for you. Okay, I did the factor tree for you. Am I not nice? Isn't this great? Okay, now that we know, now that we've done the step 1 for you, I want to make sure that you know the step 2. That's the most important step, right? Step 1 is just doing factor tree. It's not that hard. Can you then find me the GCF? Now that I did the step 1 for you, okay, hold on. If you're done, just wait. Some of you could be, right? You're done really. That's fine, but it says 2 to the third, 3 to the second, 5 to the third, 7 to the second. The other number, 2 to the third, 3 to the 8th, 5 to the first, 11 to the 12th, 13 to the 4th. Okay, can you find me the GCF for this one? Okay, some of you are done. Go ahead, everybody. I'll wait, and then help each other out. That's fine. Okay, do it as a group if you're. Okay, so all you have to do is, now that the step 1 is done for you, you have to look at your common factors first. And I told you, you could literally see your common factors. That's the reason why we did all this prime factorization, right? Is 2 a common factor for both of these numbers? Yeah, because 2 is in both. You could see them, right? Here's 2, here's 2. Is 3 a common factor? Yeah, here's 3, here's 3. So I'm going to write these 2 times 3 times. Is 5 a common factor? Yes, in both. Is 7 a common factor? No. Is 11 a common factor? Is 13 a common factor? No. Am I done? No, now you have to choose the highest exponent or the lowest? Lowest, so that it goes into both of these numbers. So do I choose 2 to the 3rd or 2 to the 3rd? Well, there's nothing to choose from. It's both 2 to the 3rd. What about 3 to the 2nd or 3 to the 8th? 5 to the 3rd or 5 to the 1st? That's it. That's your GCF. And of course, you multiply them out if you can. So 2 to the 3rd is what? 8 times 3 to the 2nd? 9. 5, which is? 360. Yeah, it's 360. Raise your hand if you got 360. Is this easy or hard? That's okay. That's why we do, guys, prime factorization. You could actually see the common factors. All you have to do is choose the lowest exponents. That's all. Now, does this work for only 2 numbers? Does it work for 3 numbers or 4 or 5? Oh, actually, no. It's the same thing. Now, again, I'm so nice. I did the prime factorization for you. Go ahead and find the GCF for these numbers. GCF for these numbers. I'll wait. Jason, what do I do here? So now that we've done the first step, right? That's the hardest part, right? But you all know how to do a factor tree, don't you? Okay, so step 1, we did it. Step 2 is write down the common factors. Jason, can you tell me a common factor for all 3 of these numbers? Is 2 a common factor for all 3 of these numbers? No, because 2 is in both of these, but 2 is not in the 3rd one. So we cannot use 2 as a common factor. What about 3? Yes, 3 is. You see here's 3. You can literally see them, right? 3, 3, 3. So 3 is a common factor. Times, what? Is 5 a common factor? Yes. Yes, it is. 5 is right here. 5 is here. 5 is here. So 5. Times, what about 7? What about 11? No, so 3 to the which power? Do you think it's a good idea to write down the invisible one? Yeah, this is 3 to the 1st, isn't it? Here's 3 to the 1st again. Which one do I choose? 3 to the 1st or 3 to the 2nd? We want to make sure it goes into all these numbers, right? What about 5 to the what power? First again, isn't this okay? 5. How many people got the answer as 15? Okay, good. Any questions, guys? What does this mean? 15 is the number that goes into all 3 of these numbers. Yeah, all 3 of these numbers. This is the biggest number that will go into all 3 of these numbers. Is that okay? Any question? All right. You know how on the other examples, I asked you to list all positive factors? This one is a little bit different. Let's see whether you can figure this out. It's going to ask you to do this on your homework tonight. It's going to say list all pairs of factors of each integer. So it's going to ask you to write the pairs of factors of each integer. So it's not asking you to list all factors, right? All positive factors, that's before, right? So it's going to ask you to do that. Let's start with 20. Can somebody give me one pair of factors for 20? Let's start with the easiest one, Matthew. 20 and 1. If I'm going to do it as 1 and 20. Okay, now notice it said all factors. So did they say anything about everything has to be positive or anything?
No.
So if I could have 1 and 20, what else could you have? Negative 1 and? Do you think it's a good idea to sort of do them all together at the same line here? Okay, so do you see how so far I found 2 pairs, right? If 1 goes into 20, what else goes into 20? So next number is I'm going to try 2 and 10. If 2 times 10 gives you 20, what else? Negative 2 times? Right, negative times negative is positive, right? Okay, what about, then does 3 go in? No. What about 4? Yeah, 4 and? 4 and 5, not negative 5. But if you can have 4 and 5, we could also have? Negative 4 and negative 5. Isn't this easy? Now, do you see how it sort of wraps around? The next number is 5 was 5 and 4 and 10 and 2 and 20 and 1, right? So guess what? How many pairs do you get? You get 3 pairs. You get 6 pairs, right? Because you have the negatives, right? So notice it doesn't say anything about negative or positive, so you have to give all pairs.
So you see the number of pairs?
No, they didn't ask you for this. So I'm just saying that there are 6 pairs. But that's how this is what you write. That's your answer.
Okay.
Now, can you do it for negative 20? Go ahead. I'll wait. Let's see if you can do it for negative 20. Do the same thing for negative 20. Go ahead. I'll wait. How many pairs did you get? Raise your hand if you got. What did you get, Paige? You got 6 pairs? You're right. There should be 6 pairs. So look, you could have -1, positive 20. Remember, only one of them has to be negative, right? If you could have -1 and 20, what could you have also? No. If you could have -1 and 20, you could also have? Yeah, 1 and -20. If you could have -2 and 10, what could you have? 2 and -10, right? If you could have -4 and 5, what could you have? 4 and -5. Do you see how you get 6 pairs again?
Yeah.
Any questions?
No.
Does this make sense? Okay, are we good? Can you do something like this for your homework? All right, good.